Hi guys. Okay, today we're going to talk about how to find the argument of Z1 minus Z2. Okay, so Z1 and Z2, they are complex numbers. Okay, so for illustration's sake, okay, let's have an example. Okay, so let's say Z1 is equals to 1 plus square root 3i, all right? And let's say Z2 is equals to -1 plus I. Okay, so how do we find the argument of Z1 minus Z2? Right, we all know that, okay, finding the argument of Z1 is simple and finding the argument of Z2 is also simple. We can also find the argument of Z1 times Z2 or Z1 divided by Z2 quite easily. But what about the argument of Z1 minus Z2, right? So how does it work? Okay, so let's try to draw a complex plane, right, to help us in the visualization. Okay, so here we're going to have the complex plane. Okay, so this is the real part and this is the imaginary part. Okay, so let's try to be as realistic as possible. Let's draw Z1 first, all right? Okay, I'll draw Z1 in red. So Z1 being 1 plus square root 3i, so that would be in the first quadrant, right? So I guess it would be something like this, right? Okay. So basically, this is Z1, right? Goes to 1 plus a square root 3i. Okay. Okay, maybe let me redraw this. Okay. Perhaps it should be a little bit more like this. Okay. So this is Z1. Okay, what about Z2, right? Z2 is -1 plus I. So -1 plus I should be, okay, let me draw it in blue this time. Should be somewhere here, I guess. Okay. Okay, so it may not be drawn to proportion, but please try to bear with it. Okay, so we have a Z2 here, right? Z2 is -1 plus I. Okay, so what exactly is Z1 minus Z2, right? Okay, so Z1 minus Z2. Okay, so if you think about vectors, right? Okay, you know, a position vector, let's say AB, right? Position vector AB is equals to OB minus OA, right? If you still recall a position vector. So maybe, okay, I'll think of Z1 minus Z2, right? As, okay, what should it be? Z1 minus Z2. Right? It should be Z2, Z1, right? So think of it as, we are going from Z2 to Z1, right? So, okay, let me try to draw Z2, Z1, okay? If you want, we can call this Z3, okay? So let's call this Z3, okay? So how does Z3 look like, okay? Well, in vectors term, okay, Z2, Z1 would be from Z2 to Z1, right? So it'll be this straight line here, okay? Okay, so let me draw another line that is parallel to the real axis, okay? So this would be that line here. Okay, so this line is parallel to the real axis, okay? So let me dot it. Okay, so that's this line. All right. The green line would be Z3, all right? Okay, so this is technically Z3. Okay, so what are we finding, right, at the end of the day? Okay, so what is the argument of Z3, right? We're trying to find the argument of Z3. Okay. Okay, so argument of Z1 minus Z2 is actually the argument of Z3, right? Okay, but Z3, is not exactly here, right? Because I'm just trying to think of it as a vector. Okay, Z3 should be somewhere here. Okay, Z3 should be somewhere here. Okay, so, well, you see, I drew another green line, all right? So this second green line which I drew, okay, is actually parallel to the first green line, okay? And it makes the same angle, right, with the real axis, okay? So it makes the same angle, okay? So basically this is equal to this, right? Okay, so we are trying to find the argument of Z1 minus Z2, okay? So this, okay, is basically the argument, right, of Z1 minus Z2. Okay, so this angle here, right? Okay, let's call it theta, shall we? Okay, so this is basically the argument of Z1 minus Z2. Okay, so how do we find that angle, right? Okay, first of all, okay, let's find the argument of Z1, right? Okay, so the argument of Z1, which is quite simple, I will not explain here. Okay, we just go into finding it. It should be 60 degrees, right? And the argument of Z2, okay, should be 180 minus 45 degrees, which is 135 degrees, right? Okay, so basically, this is 45 degrees, okay? And argument of Z1 is 60, okay? So this entire thing is actually 60, okay? 60 degrees. Okay, now, by alternate angle, this is also going to be 45 degrees, right? By alternate angle, okay? So to find theta, okay, to find theta, okay, can I find the angle between, okay, the angle between Z3 and Z2, okay, and then subtract by 45 degrees, right? Okay, so angle between Z3 and Z2. Okay, so yeah, think about it, right? Does it make sense? Okay, so, and by the way, okay, by the way, Z1 minus Z2 is equals to 2 plus square root 3 minus 1i. Okay, so I can write it down here. This is actually Z1 minus Z2. Okay. Okay, so that makes sense, right? The pink angle is actually the argument of Z1 minus Z2. Okay, so let's go back to find the angle between Z3 and Z2. Okay. So if you think about vectors again, how do we find the angle between two vectors, right? So let me express Z3 and Z2 as a column vector. Okay, so Z3 would be 2 square root 3 minus 1, right? And Z2 would be -1 and 1, right? Okay, so what do you want to do, right? Okay, let's say that the angle between Z3 and Z2, okay, so let the angle between Z3 and Z2 be theta. Oh, sorry, not theta, alpha, right? We have already used theta. So let the angle be alpha, right? So it follows that Z3 dot Z2 is equals to the magnitude of Z3 times the magnitude of Z2 times cosine of alpha, right? Okay, so okay, let's do the calculations, right? Okay, so I can say that okay, do a side working here. Z3 dot Z2 is basically equals to -1 times 2 plus square root 3 minus 1. Okay. And the magnitude of Z3 okay, is basically square root of 4 plus square root 3 minus 1 square. Okay. And the magnitude of Z2 is square root 2, right? Okay, so alpha, okay, or rather, let's start with cosine alpha first. Okay, cosine alpha is equal to -2 plus square root 3 minus 1 divided by square root 2 times square root of this whole chunk, right? But don't worry, you can use your calculator to calculate all these values. Okay. So it turned out that you should get something around -0.421, right? So cosine alpha is negative, right? So, so alpha could be in which quadrant? Alpha could be in the second or third quadrant, right? Yeah, but obviously alpha is made up of theta plus 45. And it cannot be in the third quadrant, right? Because that will exceed the total angle in the triangle. So it should be in the second quadrant. Okay, so this is what we're looking for. So how do we find alpha, right, in the second quadrant? Okay, so it should be 180 minus 65.1 degrees, right? So it should give you 114.9 degrees. So alpha is actually this value, but that's not our final answer, right? We want to find theta. So theta is actually alpha minus 45, right? And that would give us 114.9 minus 45 degrees. And that would be 69.9 degrees. So this is the angle theta, right? Which is the argument of Z1 minus Z2. Okay. Yeah, we're done.